First of all, thanks BIT for funding this research for this SMART grant. And this is actually research together with Jelte Wiggerts and also Marcel van Assen, both from Tilburg University. So first some advertisement for our research group. It's called Social Sciences Meta Research Group. And we now have 3 senior staff members. So we have Marcel van Assen over there and Jelte Wiggerts over there. And then we also have Marjan Bakker. And all the other people on this picture are the PhD students. And one of these PhD students is also award-winning Michel. So if you're interested in our research, please visit our website and take a look. So what I will do, I will first start with the most important slide of my presentation with a message. And the message actually is that there is evidence for publication bias in various fields. And there exist methods to correct for publication bias. And one of these methods is the p-uniform method. And this method accurately estimates the effect size in the presence of publication bias when the true effect size is homogeneous. So what we did in this project is we applied several publication bias methods to meta-analyses in psychology and in medical research in order to examine to what extent there is publication bias. And there's surprisingly not a lot of evidence for publication bias in these meta-analyses. But still, we think that it's important to further develop methods to examine publication bias because it remains an important problem. So a brief overview of my presentation. I will continue with explaining publication bias and its consequences to you. Then I will say something about the available publication bias methods. Explain about the meta-analyses that we extracted to apply the publication bias methods to, discuss some results, and also say, of course, something as conclusion and discussion. So first of all, publication bias. Publication bias is just the selective publishing of studies based on the statistical significance. So in its most extreme form, it means that studies with a p-value below 0.05 get published, whereas studies with p-values above 0.05 do not get published. And there's actually overwhelming evidence for publication bias. So to give an example from the field of psychology, in psychology we know that 95% of the published results contain statistically significant findings. So if the true effect size, if we assume that the true effect size, the probability that the true effect size is larger then 0 is equal to 0.5, and also if we assume that the average power, statistical power, is also 0.5, then only 1 out of 40 of the statistically non-significant results do get published. And this is quite shocking, I would say, and also because the consequences are really severe. So first of all, if you as a researcher reads in the literature that there is a particular effect between variable x and variable y, because you see statistically significant results everywhere, then of course you may conclude, okay, there is really such an effect. However, if the statistically non-significant results are just in a file drawer and are not published, then this is a false impression. So another important thing is that because of the publication bias, the statistically significant studies get published, and these have in general larger effect sizes. And as a consequence, also the effect size estimates in the meta-analysis get overestimated. And finally, because of publication bias, researchers may engage in questionable research practices. Because they know, okay, I should get my p-value below 0.05, otherwise I cannot publish my study. And therefore researchers may engage in questionable research practices because of the publication bias. So different tests exist to test for publication bias, to test the null hypothesis of no publication bias. So for instance, we have the Aert test and the rank correlation test, which examine the association between the effect size and its precision. Then another test is the test of excess significance, which checks whether the statistical power in the primary studies is in line with the observed number of statistical significant results in a meta-analysis. And then we also have the p-uniform method, and I will explain this method later on. But what is important is that if a publication bias test is not statistically significant, then it doesn't mean that there is no publication bias in your meta-analysis. because these publication bias tests in general have low statistical power, especially if the number of studies in a meta-analysis is small. So if you have a small number of studies in your meta-analysis, then publication bias tests have low statistical power. So this actually creates a demand for methods that can estimate the effect size in the presence of publication bias, so, such that you get an accurate effect size estimate. So different methods were developed for this purpose. But first of all, it's important to realize that if there is no publication bias or only a small amount of publication bias, then it's just better to stick to the traditional meta-analysis method. So traditional fixed effect or random effects meta-analysis methods. These estimates are then pretty accurate and they are most precise, meaning that the confidence interval around those effect size estimates is the smallest. So you probably have heard of the trim and fill method, and this method is just, I would advise to not use this method, because we now know, based on several studies, that this method imputes studies to correct for publication bias when there actually are no studies missing, whereas it doesn't impute studies when there are studies missing because of publication bias. So another promising method is the PET-PEACE method, and the PET-PEACE method is quite recently developed. And this method is actually a topic of further study because it looks promising. There's only one drawback, I would say, and that is if the study sample size are equal to each other, then the method will not work. And this is actually a quite common situation in psychology, for instance. And then finally we have selection models, and these selection models are quite complex, and they also require a substantial number of studies. So you need at least, let's say, 30 studies to apply such a model. And now, I think about half a year ago, there was an R package release called WeightR that can be used to apply such a selection model to your meta-analysis. Okay, so then we also have two other methods, p-uniformip-curve, that can be used for estimating the effect size corrected for publication bias. And those two methods were actually independently developed of each other and are based on the same methodology, but slightly differ in its implementation. And the idea of the methods is based on the statistical principle that the p-values under the null hypothesis should be uniformly distributed. And if we only focus, so both methods only focus on statistically significant results, and then the effect size is obtained if we just extend that statistical principle such that, okay, now we state that the true effect size or the effect size estimate is obtained when the p-values given that true effect size are uniformly distributed. So besides estimating the effect size, p-uniform can also be used for estimating a confidence interval, test the null hypothesis of no effect, and also a publication bias test. And we made two important assumptions, or two assumptions are made for both methods, p-curve and p-uniform. First of all, that all statistically significant results have an equal probability of getting published, and also that the effect sizes should be statistically independent of each other. But this is actually a common assumption in meta-analysis. Okay, so it's also, I think it's always important to also mention the limitations of the methods. So in this case, one important limitation is that the effect size gets overestimated if there is medium to large heterogeneity, so between study heterogeneity in a meta-analysis. And a second limitation is that the methods are also sensitive to p-values close to the alpha level. So if you have many p-values close to 0.05, then the methods will yield highly negative effect size estimates. So what we recommend is to set the effect size estimate equal to 0 if the estimate of the methods is in the opposite direction than the estimate of the traditional meta-analysis. And also, if there is only a small number of statistically significant effect sizes in a meta-analysis, then the estimate is still accurate, so the estimate is still unbiased. However, then you will get a wide confidence interval around this estimate. So what we are currently working on is that we are working on extending the p-uniform method such that it can also deal with heterogeneous true effect sizes. And we are also working on a Bayesian version of the p-uniform method. And we are working, so we hope to solve some of the limitations with these new versions of the method. So if you want to apply the method to your own meta-analysis, you can either use the R package p-uniform, which is on GitHub, or you can use the web application. And the web application is, I would say, pretty easy to use, and also for users who are not proficient in R, because you need any knowledge of R to use that web application. So it looks like this, the web application. So on the left-hand side, you just enter characteristics of your meta-analysis, basically, and then on the right-hand side, you get the results of p-uniform. Okay, so now more about the SMART project. So what our goal was to study the prevalence and also the overestimation in meta-analyses published in psychology and also in medical research. And we compared psychology to medical research because medical research just has a longer tradition of taking into account publication bias and also pre-registration. And pre-registration can, of course, be counteract the effect of publication bias. So the psychological meta-analyses were all selected from Psychological Bulletin, published between 2004 and 2014. And so all meta-analyses were included, 84 meta-analyses were included, from which the data could be obtained from either from the paper or by contacting the corresponding author of the meta-analysis. And what we did is we created homogeneous subsets of studies within each meta-analysis based on the reported moderators, because what we know is that publication bias methods do not perform well if there is heterogeneity. And that's the reason why we created these homogeneous subsets. And we created homogeneous subsets of at least 5 studies, 5 effect sizes. So in order to get data representing medical research, what we did is we extracted sampled systematic reviews from the Cochrane library, and the Cochrane library are systematic reviews related to medical treatments. These systematic reviews were also published between 2004 and 2014 to match the range in years of the psychological meta-analyses, and we also created homogeneous subsets. So in total we got 370 subsets for medical research and also 370 subsets for psychological research. So to show some descriptive results of the subsets, so these 2 histograms show the number of studies in the subsets. So what you see is that the patterns for both psychology and also medicine are, I would say, pretty similar. And what we see is that for the vast majority of subsets contain between 5 and 10 studies, effect sizes in a subset. So what we see is the mean number of effect sizes, mean number of studies is 9.2, and in psychology, and the mean number of effect sizes in medicine is 7.6. So if we now take a look at the number of statistically significant results within each subset, then we see again quite similar patterns between psychology and medicine. And what we now see is that there are approximately for most of the subsets, there are between 0 and 2 statistically significant effect sizes in the meta-analyses. So the mean number of significant effect size for psychology is 2.6, and for medicine is 1.2, and the number of non-significant effect size is 6.6 for psychology and 6.4 for medicine. So actually, these conditions, also the total number of studies and the number of statistically significant studies in a subset, are really tough conditions for publication bias methods, but only because only a really small number of studies or statistically significant studies are in those subsets. So really challenging conditions. And what also is a problem is that if you use p-uniform's publication bias test, then we need at least one statistically significant effect size in order to apply this method. So what we see is that it's very often the case that there's not a statistically significant effect size in a subset. And actually this morning when I was looking through the slides, I saw this percentage and I was pretty surprised. I thought, ooh, that's really large. And actually I checked it again and it should be 40.5%. So in 40.5% of the cases, there's no statistically significant result in the subset. So the results. So what we see in this table is in the first row, we see the results of the meta-analysis in psychology. And in the second row, the results of the meta-analysis in medicine. And what you see is that the percentages indicate how often the publication bias tests are statistically significant. So what you see in the results is that there is slightly more publication bias in psychology. However, the differences between psychology and medicine are in general not very large. And also overall, there's not a lot of evidence for publication bias in these subsets. So to study the overestimation in effect size, what we first did is we first had to transform all the effect size to one common effect size measure. So we transformed all the effect sizes to Cohen's d, and then we only included the subsets with statistically significant effect sizes. Because we applied p-uniform to correct for publication bias. And p-uniform's estimates were actually set equal to 0 if the effect size was in the opposite direction than of the meta-analysis, and we created a new variable describing the overestimation in effect size by comparing the estimate of p-uniform with the estimate of the meta-analysis, random effects meta-analysis. And what we see based on these results is that there's actually a tiny bit of overestimation in effect size. So this reflects the overestimation in effect size. However, the median overestimation is still very close to 0, I would say. So not a lot of evidence for publication bias in these subsets. So there is slight overestimation. And this overestimation is slightly larger in medicine than psychology, but still the differences are really, really small. And then the conclusion actually is, okay, is there really such a small amount of publication bias in meta-analysis published in psychology and medicine? Of course, it could be the case, but based on previous research, we know that there is most likely quite a lot of publication bias in these literatures. So we also have some alternative explanations that could be the reason that we do not observe such a lot of publication bias in those published meta-analyses. So first of all, it is of course possible that these are just meta-analyses in fields where there is no or only a small amount of publication bias. It's possible. But an alternative explanation could be that what we did is we selected the homogeneous subsets, and imagine a situation where we have some statistically significant results, and if then there are 1 or 2 statistically non-significant results, so we have a bunch of studies over there, effect size over there, and some studies over here, then because of the publication bias with the statistically significant effect sizes and some maybe unpublished or at least statistically non-significant results, you will get heterogeneity because you combine these two. And what we did is we excluded the heterogeneous subsets. So it could be the case that we excluded the subsets with a lot of publication bias. So another alternative explanation is that the meta-analyses were actually not about the main results of primary studies. So it's most likely that publication bias will work on the main results of the primary studies and not on secondary results. So if the meta-analysis is on secondary results, then of course you will not observe a lot of publication bias. And finally, another alternative explanation could be that the authors of the meta-analysis just included a lot of unpublished manuscripts. And then of course we do not find the publication bias in the meta-analysis, but that's still in the literature, because if unpublished work is included, then this counteracts the publication bias. So to conclude, there is, based on literature, evidence for publication bias in various fields, So there are methods to correct for this publication bias. So we do not observe a lot of publication bias in the meta-analyses that we studied from psychology and medicine. But still what's important is to further develop methods that can that can accurately estimate the effect size when there is publication bias, and we are currently working on extending the p-uniform method such that it improves and that it can also deal with heterogeneous true effect sizes. So, thank you. Questions?
Thanks very much for your presentation. Really important work. I wonder why you didn't just repeat your analyses on those meta-analyses that included unpublished studies and those that didn't.
Yeah, it's a good question. The point is that you have to be sure that some studies are actually unpublished. So that means that you have to that you have to check by hand most of the cases whether the studies are unpublished or not, because sometimes studies include a variable with published work or unpublished work, so then it would be quite easy to do so, but otherwise you have to check it by hand. But it is maybe an option to do that in order to get better insight in these results. Yeah.
But it's usually a moderator that people include.
Yeah, it's often a moderator that people include in their meta-analysis. Yeah, definitely.
Thank you. I was wondering how large were the number of studies included in the meta-analysis from the Cochrane review for the medicine. My understanding of the Cochrane library is that it actually includes many meta-analyses that don't really have many studies included in them. And an alternative could be something like you could have chosen the largest, the meta-analysis with largest number of studies or something like that. And I was wondering the extent to which the result of not having publication bias is due to the underpower, due to the lack of number of studies. Thank you.
Yeah, thank you for your question. So, so what is important to realize is that in the Cochrane library you have systematic reviews, and within those systematic reviews there are different meta-analyses basically. And usually, indeed, the meta-analyses within such a systematic review only contain a small number of studies. So I think it's pretty unlikely that you have a meta-analysis with, let's say, more than 15 studies. That's pretty unlikely. But it also really depends on the topic of the systematic review and on the topic of the meta-analysis. But it couldn't be, what we could do is we could just focus on the meta-analysis from the Cochrane library with, let's say, more than 15 studies, and then do the analyses again. That's definitely an option, yeah.
Thanks a lot, I really enjoyed that, and I appreciated your point at the end about how the studies that are included may not be representative. And I mean, in fact, I think you opened with a point saying 95% of published psychology studies have significant results. And then you showed us that the studies included in the psychology meta-analyses, there were 2.6 out of 6.6 that were significant. So clearly they seem quite different. I did wonder if you could go, so I think that's an important point. I was wondering if you could try to quantify this a little bit more in terms of how influential the studies are that are included in the meta-analyses here, to give you a sense of how representative they are. So, for instance, based on various citation metrics, you could look at the papers you included in your analyses versus, say, all published papers in psychology or relative to top journals, to get a sense for what share of citations in psychology these account for. I'm just trying to get a sense for how representative these are. They do seem like they're selected in some way, and could you speak about how you could quantify...
You mean like the meta-analyses or the primary studies within?
The underlying papers. So like to the extent that you said 95% of psychology studies have significant results, but it's only 2.6 out of 6.6. They're not representative. Do they happen to be like the most influential literatures that you're covering in the meta-analysis, the least influential literatures? And that'll just help us get a sense for, the claim at the end. I think you were right to caveat the claim that there isn't that much, there doesn't appear to be much publication bias in psychology because these are selected studies. And I'm starting to think through how you can quantify how selected they are, how representative they are.
Yeah. So that's a good point. We could look at citations. It's definitely possible. So in general, the meta-analyses that are published in Psychological Bulletin, it's quite a broad journal. And so also many meta-analyses get published over there. And I think those meta-analyses are also on pretty general topics. So pretty, let's say important topics for psychologists. So in that case, I would say that the most important topics are indeed in those meta-analyses, so that those meta-analyses are really representative for all psychology. But we can definitely look at citations to see whether there's whether that can explain the results even better. Yeah.